This conference will now be recorded.
Hello everyone. In this video we are going to see a short multicore debug demo with the TRACE32 debugger on the PolarFire SoC icicle kit. And for this reason I have here a first graphical interface of TRACE32, and I'm going to start my startup script. So let's enter this first command. Okay, now a second graphical interface has been started, and this will be used on the U54 cores of the CPU. Now we are stopped at the very beginning of the Linux kernel. So we have a terminal view where U-boot just started the kernel. And on the right side, we have a list view, again showing the program counter stopped at the first instruction of the kernel. In our script, we can now continue the execution to start Linux. So I enter this continue command. Let's wait a short time until the kernel is fully booted. In this moment, the CPU is running. All the U54 cores have been started by Linux, and we are waiting to reach the prompt in the terminal. Okay, now the prompt has been reached. The application is stopped. On the on the right side, we have a list view where we can see the program counter. We can debug in assembly mode, and in this case, we can see virtual memory address space. And we can also debug at high level, just skipping the assembly code. Now we are stopped on core 0, and this is shown in the bottom part of the GUI where we have this selector. I can also switch the core view to the core number 1 or core number 2 or core number 3. So definitely we have 4 cores. We can also double click this button and see a selector where all the 4 core can be seen. Each of them will be started with go. Each of them will be stopped with break. Okay, for now, I just continue this execution with a generic go command. All the cores have been started. So now I enter the prompt, and I can see that in my file system, we have a few applications, and I will use those applications for debugging later. But now it's time to come back to the first GUI, which is related to the E51 core. And this is the GUI where we started the first script. Also, this GUI is waiting for a script to continue. So I will continue the execution of the main script on the E51 side with this command. Let's do it. And finally, we have a configuration where on the left, we have the E51 graphical interface of TRACE32, which is stopped at the main of bare metal application. Again, we can debug in assembly or we can debug at high level language. On the right, we have the U54 GUI, which control 4 cores, as already seen before. And in this case, we selected the different program view, so a list view for core 0, and at the same time, a view for core 1, and for core 2, and for core 3. Please consider that we can also open a generic list view, and it will be always focused on the core which is currently under debug. I can choose for core 0, core 1, and again core 2 and core 3. You can see that the color of in the window changes according with the selected core, and also the stack frame view is always related to the selected core. Please check again the change of color in the list view and in the frame view at the same time. Okay, now it's time to run the right side. Again, we have a terminal, and I can just debug the first application, for example. So let's break it and use this menu where we can see the current processes which have been created by the Linux kernel. And we also have a specific Linux menu, and I will use it for process debugging, specifically to debug a new process. The process will be by SIVE process. So I enter this dialog and I start my application. The boot code of SIVE has been started, and now the debugger asks for the ELF file of SIVE because I didn't specify the directory where this ELF file is located. So the debugger asks for it. I select it, and this allows us to continue the execution. And we see that now on core number 3, we have the main of SIVE demo. We can also appreciate better if I open the generic view. Okay, I can put, for example, a breakpoint here, and I can continue my execution. And you can see that whenever I start the application, the breakpoint is it, because now we have an infinite cycle program. Okay, now it's time to start another process. So run this GUI, and in the terminal, start another process. Hello loop. Okay, you see in the terminal now we have two different processes running. I can break the execution and again have a look at the display processes view, and we see obviously the first process, but also the second process. In this case, I will use another context menu to load the process symbol of this second process. And now I have a couple of processes able to be debugged. If I list main, there is something to be chosen because we have two different processes, so we have two different main. Let's choose the first, and the first one is the sieve main. And now let's choose the second. The second one is hello loop main. Okay, now again, let's put a couple of breakpoints. One could be set here, for example, in the first process, and the other one could be set here in the second process. If I run the execution, you see that different breakpoint will be hit. For example, this is a breakpoint in hello loop process, which is executed on core 3. Now let's continue. And we have another breakpoint now in the sieve process, which is executed on core number 1. And again, I can continue, and each second different processes will be hit. So I can debug both of them at the same time. Now I remove those breakpoints, delete all, and also I can remove these views. It's time to start something on the E51 side, so I can go the left side and break it. I can go up to the caller, I can put some breakpoint and again go, something like this, and then go. Now remove these breakpoints. Now it would be interesting to see if we can synchronously debug the left GUI and the right GUI, and this is possible using the sync command, where I have preset the basic settings for inter-processor communication. I just have to enable the synchronous debug, so the right instance will be connected to the left instance. And again, on the left side, I open sync and I enable synchronous debug, where the left instance will be connected to the right instance. In this way, whichever GUI I start, the other will follow. For example, I start the right side and you see that also the left side is started. I can break, for example, the left side and you see that also the right side is stopped. So this is a synchronous debug where both application in E51 core and the U54 core are started at the same time and they are stopped at the same time. Just as a last topic, we can also see asynchronous stepping of all these applications. Let's have a look, for example, at CVMain, which is one of the application, one of the function run in our application. First of all, go there, okay? And now we have the application running here on core 2, and let's try to step this code. You see that also the other cores are stepped, sorry. So this show an example of synchronous stepping between all the core on the right side and also on the bare metal application on the left side. And I think that's all for now. I hope I gave a valid view of the feature of TRACE32 multicore debugging. Thank you for listening at this recording.